Okay, would like to continue on 5.2 reactions of acids and bases. And in this video, I would like to talk about the last row in the science understanding. The dot point says similarities in the reactions of different acids with bases. So different bases are there. Allow products to be predicted from known reactions. As well as on the right hand side, it says identify the product of obtained and write full and ionic equations for reactions between a given acids, a nominated metal oxide, hydroxide, carbonate, or hydrogen carbonates. And also the idea that neutralization is an exothermic reaction. All right. So content-wise, we are looking at this slide. So, neutralization reaction. What is it? Okay, so it is a neutralization reaction, and it is a endothermic reaction, which means when acid and base reacts together, releases heat, and that heat gets transferred to the surrounding water. So the whole solution will raise its temperature. When it happens, if you were using a calorimeter setup, like coffee cup one that you used before, you'll be able to measure the enthalpy of the reaction, of the neutralization, as well. Now, in neutralization, at this point, we'll be looking at 4 different types of the reactions. By knowing these patterns, i.e. that's a classification of the reaction, you'll be able to predict and also identify the products, and that's a very useful thing to be able to do, as well as you need to be able to write full and ionized complete ionization reaction. Now, 4 main types of neutralization. First one is the acids reacting with metal oxides. Remember that metal oxides are naturally base. When metal oxides and acids react, you get salt and water. Metal oxide and acid, you get salt and water. Pretty much that. Secondly, acids reacting with metal hydroxides. You get pretty much the same same reaction happening. So a metal hydroxide and acid, it will just produce salt and water. Next, acids reacting with metal carbonates. Now, whenever there is a carbonate, you get carbon dioxide as one of the products. In this case, you get from metal carbonates and acid, you get salt, water, and carbon dioxide. Lastly, acids reacting with metal hydrogen carbonates. So a carbonate with one extra hydrogen atom to it. Hydrogen carbonate, it's also known as bicarbonate, like bicarb soda. You get pretty much the same reaction again. So metal hydrogen carbonate reacting with acid, you get salt, water, and carbon dioxide. By knowing that, and with given any examples, any given base, you need to be able to write normal equation, the complete balanced equation, as well as ionic equation. So it's better to probably look at what sort of rules are there regarding writing an ionic equation. These are the examples that you can do, and we'll probably start the lesson with it. So firstly, sodium oxide solid and sulfuric acid. I remember there is quite significance in writing states of the species in ionic equation. Secondly, potassium hydroxide solution and hydrochloric acid, that's a solution 2. Calcium hydroxide solid and hydrochloric acid. Sodium hydroxide solution and ethanoic acid, which is also known as acetic acid solution. Fifth question, calcium carbonate and solid and sulfuric acid. 6, calcium carbonate solid and nitric acid, so different acid there. 7, that's the final one, sodium hydrogen carbonate and hydrochloric acid. So we'll have a go at that in class later.